Alright, hey everyone, Sebastian here for another episode of Learning Game Development. Today should be, or this episode should be episode 4, and let's just hop right into it.
Hello, in this episode we're going to be looking at arrays and lists, which are both ways of storing a collection of variables of the same type.
Okay, so I have already taken a Java course. That's probably why a lot of this is easier to me than someone who is completely unfamiliar with programming. And I do already know what arrays and lists are. And also, can arrays and lists hold more than one type? I think there are some things like there's a certain kind of array or list that can, or maybe it's only in a specific programming language, but I'm pretty sure they can hold more than one variable type, from my understanding. At least in some circumstances. But he'll explain it. He will explain it. Let's get to
Let's
it.
start with arrays. Imagine we want to store a number of different names. Instead of creating a new variable for each one, string name 1 equals Fred, string name 2 equals George, and so on, we can rather create just one string array variable, which we do just like creating a normal variable, except that after the type, we place a pair of square brackets. If we want, we can directly assign a collection of values to the array by having a pair of curly brackets, inside which are all the elements separated by commas. Somewhere in our code, we can now access any element in the array by writing the array's name, so in this case possible names, followed by a pair of square brackets, inside which
Okay. So he's setting the character name variable to, he's going to put a number in here, I think.
which goes the index of the element we wish to access. Now, there are 4 elements in this particular array, but arrays are indexed starting at 0, meaning that the first element in the array has an index of 0, the second has an index of 1, and so on. So if we try and access index 4 or greater, we will get an index out of bounds exception. Now, let's say we want to pick a random name from this array for our character. The first step would be to generate a random number.
Okay. What is this? Rand range? Is it rand range?
Between 0 and 3. So if we're working in Unity, we can simply use the random.range method and
Random.range, never mind.
pass in 0
In
as our min
Unity.
value and possible names.length as our max value. The length of our array is 4, but remember that the random.range method returns a value that is greater than or equal to the minimum value and less than the max value, which means that we're actually getting a value between 0 and 3 like we want. So now that we have our random index, we can simply write string character name is equal to possible names with an index of random name index. Okay, let's look at another example. This time I'll create an array of integers, which I'll call powers of 2. So we just want to store the first 5. Well, we've already seen one way of assigning these, so let's look at another. We can set the array equal to a new integer array with a size of 5, at which point all 5 elements in the array will be equal to 0, since that's the default integer value. Somewhere in our code, we can then write powers of 2 with an index of 0 equals 2, powers of 2 with an index of 1 equals 4, and so on. Much smarter, of course, would be to use a loop to initialize all of these, and we'll be seeing an example of this in the next episode, which is on loops.
Okay, I mean, you just do, for loop. Is he going to do a for loop? I mean, you could also do a while. Let me think. So I'm just going to do for. So for people just do I as an item. I'm just going to guess for I in powers of 2. And then curly brackets. Then you do powers of 2I equals. Okay, you have to do 2 first. Right? Powers of 2I equals. I guess. You would have to do an if statement maybe to not F it up. to not mess it up. So maybe you would do for I in powers of 2, curly brackets, if I is less than 0, no. Like I'm thinking, okay, let me just pull up. Okay, I'll pull up. Um, Let me just do this here. So, okay. I had that long for a reason. So it would be, you guys can't see my other screen. Okay. It would be, why, I guess, sure, yeah, void sum method. I'll just uh, write what's supposed to be in here. So it would be for I in powers of 2. Then you would do if I is less than 0, right? Is that right? Okay, and then that has to go there. Do I, wait, oh, I have to tab every single time. If I is less than 0, powers, this would probably not work. Powers of 2, I equals 1. Sorry, I equals, sorry, 2. That's probably not correct. Else, powers of 2, powers of 2, I equals, what would it be? Powers, I mean, this wouldn't work, but powers of 2, I minus 1 times 2, right? If you want, I mean, or you could just set powers of 2 0 equal to 2, and then you wouldn't even need that part, right? But this wouldn't work because i's never going to be less than 0. So if, hmm, so you could just set this to 2. You could just set 0 to 2, And then you could just say this. Like, you could just do this kind of
Note
thing.
that we
What would it be? Like, mm, yeah, I mean, the index is just never going to be less than 0, though, the I. So you could just do, I mean, this would work. So 0, it would just be setting this to 2 every single time. That's the only issue. So it would be 0, and then this would also be 0. Okay, wait. Excluding 0. This would have to be done outside, right? No, it still wouldn't work. What error would you get? Would this be an out of bounds error? Hmm. Okay, and if you did a while loop, okay. I guess you could set this to 1 and maybe it would work. No, but then the index would still be -1 at some point. Huh. Interesting. I don't know.
could also leave the initialization out at the top here, but then we'd still have to define the array size before we can use it. Once we've initialized the array size, we cannot change it, except by setting the variable equal to a new array with a new size, which of course will destroy all the elements currently stored inside the array. Now, arrays don't have to have just a single dimension. Say we want a two-dimensional integer array to keep track of the pieces in some board game, for example. The syntax for this would be like so. The size of each dimension is separated by a comma, so here I've created a 3x3 board. A single comma is also placed between the square bracket
Okay.
dimension to keep track of the pieces in some board game, for example. The syntax
Okay, so I do want to try and make chess in Godot to help me learn, and that's really helpful. But I still don't know how to call it, but
for
he's
this
gonna
would
tell
be
me,
like
I
so.
guess.
The size of each dimension is separated by a comma, so here I've created a 3x3 board. A single comma is also placed between the square brackets at the declaration, indicating that there is space for two dimensions. We can now visualize this array as looking like so, with all elements currently initialized to their
Someone texted me.
default value of 0. The indices work how you'd probably expect, with the first index determining the row and the second index determining the column.
Okay, that makes sense. That makes sense. Hmm. But how would you... Hmm. I guess? Okay. I'm gonna have to figure it out.
So in some method, if we wanted to set the value of the bottom left square to 1, for example,
Yeah, I'm gonna have to do some thinking to see how chess would actually work with with this.
that would be as simple as writing board with an index of 2, 0 is equal to 1. Now, perhaps the game requires a starting configuration of pieces, with different pieces obviously represented by different numbers. Well, the syntax for this is the same as a one-dimensional array, but now the entries for each new row are surrounded by curly brackets as well. To make this easier to read, we could separate each row onto a new line, which gives us a nice visual representation of the array. You're not limited to just 2 dimensions, by the way. For more dimensions, simply add more commas. To make this easier to read, we could mention pieces, with different pieces obviously represented by different numbers. Well, the syntax for this is the same as a one-dimensional array, but now the entries for each new row are surrounded by curly brackets as well.
Hmm. Okay. Yes.
To make this easier to read, we could separate each row onto a new line, which gives us a nice visual representation of the array. You're not limited to just 2 dimensions, by the way. For more dimensions, simply add more commas.
Fourth dimensional array. Fifth dimensional array. How would that even work, though? That would be massive, though, right? Okay. So let's just say a 1 by 1 by 1, right? So if you just did 1, 1, 1.
To read, we could set to just 2 dimensions, by the way. For more dimensions, simply add more commas.
If you did 1, 1, 1, okay, then it would be how would that even work? Okay, so 1 by 1 would be wait, would it really just okay. Hold up. 3 by 3. So 1, 2, 3. Yeah, okay. So if you just did 1 by 1, oh, it would still just be the same. There would only be one value. Okay, so let's do, let me think. 1 by 2. 1 by 2 by 1 would be 1, and then 2, and then 1. Okay, wait. No, it kind of has to be 2 by 2 by 2. That would be the smallest 3D one you could do, because if you did 1 by 2 by 1, it would be the same as just a 1 by 2. It would, yeah, it would just be the same as a 1 by 2. But then that would also just be the same as an array with 2 values, I guess, right? Yes. So 2, 2 by 2 by 2. So what would that look like? So this is 2 by 2 right here. Like a box like this. So that would be 2 arrays and then 2 more arrays, but in another direction. Hmm. 3 by 3, but like, okay, so the same number for the other axis would be this number, right? So let's say it's 0, 1. So this would, okay. It would be 4? Would it be 4? Okay, or would there just be 2 more arrays? It would just be these but stacked on top of each other, right? So it would just be like 4 arrays if it was 2 by 2 by 2. Yeah, I think. And then a fourth dimensional one. Let's see, 2 by 2 by 2 by 2. 2 by 2 by 2 by 2. would be um okay. 2 would be 2, 2 would be 4, then there would be 8. So fourth dimensional array would be 16 because every single one of the currently existing ones would have another array behind it.
board with an
I'm
index
sure there are some crazy people out there who do like multi-dimensional arrays.
of 2, 0 is
That's
equal to 1.
probably, yeah, there are
Now,
probably
perhaps
are
the game
some
requires for
crazy
this
people
is easier to.
out there.
You're not limited to just 2 dimensions, by the way. For more dimensions, simply add more commas. Alright, let's now take a look at lists. Say we want to do something like keep track of the names of every character that our player kills, so we can display them all at the end of the game. We might think to make a string array
That's
called something like
morbid.
slain enemy names, but unlike in the previous examples, the size of the array is uncertain because we don't know how many enemies the player will end up killing. To solve this problem, we can make use of the list class, which is in the system.collections.generic namespace. Now, to create a list of strings, we write list, followed by the type string inside angle brackets. We then, of course, have the variable identifier, in other words, its name, and we can initialize this to a new empty list. Take note of the syntax for this. We have the new keyword, followed by list of type string, and then a pair of parentheses to call the constructor of the list class. Say we now have an onEnemyKilled method, which supplies us with the name of the enemy. We can add this name to the end of the list using the list's add method, so slainenemynames.add, and pass in the supplied name. Accessing a certain element from a list uses the same syntax as with arrays, just the variable name followed by square brackets with the index inside. Just like arrays, lists are indexed starting at 0. Recall that to get the size of an array, we could use the length property. You can keep track of the number of elements inside a list using the count property. Lists also have some other functionality that mere arrays do not.
Oh, I think in Python you can do multi-variable arrays and lists. Like multi-type variable arrays and lists. Okay, yeah, I forgot that you have to do the weird methods on lists. Okay, and then uh, yeah, I don't know why you have to specify the variable type before calling a variable. That just seems excessive,
Inside a
you know?
list using the count property.
I guess
Lists also
Python
have some other
doesn't have
functionality
that
that
maybe.
mere arrays do not. For example, you can use the remove method to remove a given element from the list. You can also use the contains method to check if the list already contains a given element. And there's even a sort method. So if you have a list of numbers, calling sort will cause them to be arranged in ascending order. And if you have a list of strings, they can then be sorted alphabetically. We'll even look later at how you can instruct the sort method to follow your own custom sorting rules. So
Whoa.
since lists can do everything arrays can do, as well as change size, and they have these helpful methods for things like searching and sorting, you may be left wondering why we even need arrays. Well, I think it's important to know that behind the scenes, a list is actually storing everything inside an array. Whenever the internal array gets filled up, the list has to create
Okay. If item count equals items dot length. Double array size. What? Double array size. Why double though? Why wouldn't it just add one? Item count equals item count plus plus. Okay.
Create a new bigger array and copy all the existing elements over into that new array. Purely for interest's sake, on screen at the moment you can see a heavily simplified version of the list class, just demonstrating how the array is resized as new items are added. So in general, arrays are slightly faster than lists, although in most cases this difference is negligible. The real reason you might sometimes want to use an array instead of a list is if the collection should logically have a fixed size, for example representing a game board or storing the items in a player's inventory. In these cases, the concept of adding an item doesn't really make much sense. You only ever want to insert an item at a specific index. I should mention that it's entirely possible to have a list of arrays, or an array of lists, or list of lists, or an array of arrays, or in these cases, the concept of adding an item doesn't really make much sense. You only ever want to insert an item at a specific index. I should mention that it's entirely possible to have a list of arrays, or an array of lists, or a list of
Sure.
lists, or an array of arrays, or pretty much any configuration you can imagine. I should also mention that arrays and lists are reference types. So if I have an empty integer array, say with a size of 5, and I now create a second array and set it equal to the first array, then if I set one of the elements to 99 and print out the value of that element in the other array, we'll see that it also now has a value of 99. If this seems strange to you, please go back and watch episode 17 on reference type array. So if I have an empty integer array, say with a size of 5, and I now create a second array and set it equal to the first array, then if I set one of the elements to 99 and print out the value of that element in the other array, we'll see that it also now has a value of 99. If this seems strange to you, please go back and watch episode 17 on reference types and value types.
Sure.
Anyway, to recap, arrays are for storing collections of a fixed size and can have one or more dimensions.
That just seems annoying, though. Why would it? Whatever.
Lists are slightly slower than arrays, but are able to.
Yeah, I mean, okay. I'll just explain myself. Why?
Then, if I set one of the
Like,
elements
what
to.
benefit does this give you? That setting something equal to another variable changes both of the variables, changes the value of both of the variables. Okay, or setting a variable equal to another one and then changing the second one changes the value of the first one. Like, what benefit does that
99,
give you?
and print out the value of that element in the other array,
Do
we'll
you
see
know
that
what
it
I
also
mean?
now has a value of 99. If this seems strange to you, please go back and watch episode 17 on reference types and value types. Anyway, to recap, arrays are for storing collections of a fixed size and can have one or more dimensions. Lists are slightly slower than arrays, but are able to resize themselves dynamically as you add and remove elements, and also provide some helpful methods such as contains and sort. Finally, arrays and lists are both reference types and are indexed starting at 0. That's everything for this video. Until next time, cheers.
Reference types. So, like, if I don't want that to happen, I do ref. When setting it equal? Yes, I think so. I don't know. I'll probably have to go back and watch it. I'll probably need to be reminded of it over and over and over again throughout the whole time I'm learning game development, but it's fine.
Hello, in this episode we're going to be looking at
Okay, and is this another learning episode? Yes.
the 4 different types of loops. Let's start with the most common one, the for loop. To create a for loop, we write the keyword for, followed by a pair of parentheses, and then a pair of curly brackets. Now, inside the parentheses, we have 3 sections, for loops. Let's start with the most common one, the for loop. To create a for loop, we write the keyword for, followed by a pair of parentheses, and then a pair of curly brackets. Now, inside the parentheses, we have 3 sections separated by semicolons. The first is the initializer, the second is the condition, and the third is the iterator. The initializer section is where we create a local variable, usually an integer, which is conventionally called I, but you can make it anything you want, of course, and we initialize that to some value. An integer, and the third is the iterator.
Okay. Sure,
The initializer
yeah.
section is where we create a local variable using
Shouldn't while be taught before this, though? Because isn't while the simplest loop?
an integer, which is conventionally called I, but you can make it anything you want, of course, and we initialize that to some value. In the condition section, we then state the condition that must be true in order for the loop to run. So for example, we might say run while I is less than 10. Finally, in the iterator section, we can modify the value of our variable. So for example, we might have I++, meaning that I increments by 1 each time. Between the two curly brackets, we then have the body of our loop, which I'll make simply print out the value of I. If we run this code now, we'll see that it prints out the values from 0 to 9. So if we think through this step by step, it should be clear how the loop works. First, the variable I is created and set to 0. The condition I less than 10 is true at that point, so the code in the body of the loop runs once, printing out 0. Then the iterator section runs, increasing the value of I from 0 to 1. The condition is still true, so the code runs once again. This repeats until I is increased to 10, at which point the condition is no longer true, so the loop terminates and the code resumes running from outside the loop. This sort of loop is often useful for setting the values in an array. For example, if we're wanting to store, say, the first 20 powers of 2, we could create a new integer array with a size of 20, and then loop from...
And now he's going to tell me how to do it the right way.
into I equals 0, while I is less than powers of 2.length increment I by 1. Remember that since arrays are indexed starting at 0, their last element is an index of 1 less than their length, which is why we have the loop run while I is less than powers of 2.length, and not while I is less than or equal to powers of 2.length. Now, inside the loop, we can simply have powers of 2 with an index of I is equal to 2 to the power I, using the mathf.pow method.
What?
We can simply have powers of 2 with an index of I is equal to 2 to the power I.
What? But that's not gonna work. Index 0 is gonna be 1.
Using the mathf.pow method. Of course, we don't have to start the loop at 0 and increment by 1 each time, although that is how it's usually used, as an arbitrary...
Right? Am I wrong? Uh, wouldn't it be I plus 1? There's 2 to the power of I plus 1. Power of 0 rule. Yeah. He messed up. It would be I plus 1, right? 2 to the power of I plus 1. So then it would be 1, and then the next one would be 2, and then the next one would be... So it would be 1, which would make it 2, 2, which would make it 4, 3, which would make it 8. Yep.
Of course, we don't have to start the loop at 0 and increment by 1 each time, although that is how it's usually used. As an arbitrary example, we could initialize int I equal to 100, and then while I greater than negative 80, decrease I by 30. Equal to 100, and then while I greater than negative 80, used as... Of course, we don't have to start the loop at 0 and increment by 1 each time, although that is how it's usually used. As an arbitrary example, we could initialize int I equal to 100, and then while I greater than negative 80, decrease I by 30.
Uh-huh. Oh, okay. I didn't see the I there. Whoops.
Alright, now how about looping through multidimensional arrays? Say we have an 8x8 integer array representing a chessboard, and we want to set it so that light squares have a value of 0, and dark squares have a value
Poggers.
of 1. To achieve this, we can use two nested for loops. So we start with one for loop to determine the row index, so I'll make a loop with int row new board, and we're looping through multidimensional arrays. Say we have an 8 by 8 integer array representing a chessboard, and we want to set it so that light squares have a value of 0 and dark squares have a value of 1. To achieve this, we can use two nested for loops. So 0 and dark. We have an 8 by 8 integer array representing a chessboard, and we want to set it so that light squares have a value of 0 and dark squares have a value of 1.
But why? What? But why would you do that? Okay. I will humor him. I will humor him. Okay, let me try. Two nested for loop. Sure, we got. We'll just do checkered board. Which would show up as um sure, let's do new, let's do void. What is a static method, actually? Static method Java, sure. Ooh. Got it. Okay, static is you don't do dot. Is you don't do a dot. I see. Okay, fair enough. Uh-huh. Got it. Got it. So let's do void set. Sure, set space value. Okay, then we're gonna do for. I need to visualize this. I need to visualize this actually. So 8 by 8. Two nested for loops. Right? Oh, it's gonna. Oh, yeah, yeah, yeah. I can do this, maybe. I think I maybe have the knowledge to do it. 1, 2, 3, 4, 5, 6, 7, 8. Okay, great. So this is going to be. This is the visualization here. Is that 8? 4, 8. Yep. Oh, whoops. Okay, what is going on? 3, 4, 5, 6, 7, 8. Okay, right. 1, 2, 3, 4, 5, 6, 7, 8. Yep. And then pretty much, so that's the visualization there. I am such a freak, bro. I don't need to do this. This is not a real code. This is not real code. Whatever. Okay. Four. Got it. Okay. Four. Okay, we're gonna do int row equals. Oh, actually, just kidding. We're gonna do column equals 0. Then we're going to do um, column is less than, I guess, length. What is it? Huh. Checkered, less than checkered board. Um, oh, wait, am I doing this right? Do I have to do row first? Actually? Oh, fudge. I actually don't think I know how to do this. Okay, that was just my brother telling me to wrap it up. Okay, let's see how I can do this. Column. That's gonna be first. No, row's gonna be first. Row. If row is less than, I guess, checkered board dot length. How do I do this? Checkered board I dot length. I don't freaking know. Then crow. Nice crow. Yeah. Yeah. Okay, then we do row plus plus, I guess. And then we do for, and then we do the same thing, except we do column, column. Yep, equals 0 as well. Then we do column less than, okay, now I actually don't know how to do this. Checkered board. Checkered board. Oh, sorry, this is row dot length. Okay, do I have to do... I don't know. I actually don't know. Okay, whatever. I just know that column is gonna be plus plus. And then... Hmm, sure. And then it sets... I have to do an if statement here. There's probably to do a divisible thing, but... Or there's probably a way to check if if a number is divisible by another number, but I'm not going to worry about that for now. Okay, if checkered board row dot column divided by 2 equals 0. Sorry. Oh, there's a remainder one. What's the remainder one? I forgot. I forgot, bro. Remainder symbol programming. Modulo, there it is. Okay, actually, ooh. Got it, yes. No, you saw my watch later. No, I'm ruined. 2 equals 0. then checkered board. Hmm. Checkered board row equals 1, right? No. Oh, fudge. This is a little bit more complex than I thought it was. I have to do another if statement here. Okay, I'm just gonna copy this. If checkered board row, I don't know what I'm doing. I don't know what I'm doing. I'm just gonna watch it.
To achieve this, we can use
I don't actually know how to call only a row or a column.
two nested for loops. So
But
we start with one for loop
that was my best shot there.
to determine the row index. So I'll make a loop with int row equals 0, row less than board.getLength 0, row plus plus. Take note of this getLength method, which allows us to specify which dimension of the array we want to know the length of. So index 0 refers to the first dimension.
Uh-huh. But why would this be 0? Row less than board.getLength 0. Shouldn't it be row?
To specify which dimension of the array we want to know the length of.
Which dimension? Huh. Okay.
So index 0 refers to the first dimension.
Fair. Sure.
Inside this loop, we can then have another loop with int column starting at 0, while column less than board.getLength 1, column plus plus. So hopefully this makes sense. The outer loop starts with row equal to 0, and then the inner loop begins. So we get a column value of 0, then 1, 2, 3, 4, 5, 6, 7, after which the inner loop terminates, and so the outer loop gets to run again, and row is increased to 1.
Yes. Get length 1, which means that would be
This
sure.
process repeats until row is no longer less than 8, at which point the outer loop terminates. To actually assign to the array, we can say board with an index of row, column is equal to row plus column mod 2.
Oh. What? Oh. Wait a second. Okay, wait, so let's just say hypothetically. What is it? 0? Index 0, 1. Okay, yeah. 0. Okay, so then it would be, okay, it would be 0, 1, 0, 1, 0, 1, 0, 1. Hmm. 0, 1, 0, 1. 0, 1, 0, 1. 0, 1. Hmm. 0, 1, 0, 1. 0, 1, 0, 1. 0, 1, 0, 1. 0, 1, 0, 1. 0, 1, 0, 1. 0, 1, 0, 1. 0, 1, 0, 1. 0, 1, 0, 1. 0, 1, 0, 1. 0, 1, 0, 1. 0, 1, 0, 1. 0, 1, 0, 1. 0, 1, 0, 1. 0, 1, 0, 1. 0, 1, 0, 1. 0, 1, 0, 1. 0, 1, 0, 1. 0, 1, 0, 1. 0, 1, 0, 1. 0, 1, 0, 1. 0, 1, 0, 1. 0, 1, 0, 1. 0, 1, 0, 1. 0, 1, 0, 1. 0, 1, 0, 1. 0, 1, 0, 1. 0, 1, 0, 1. 0, 1, 0, 1. 0, 1, 0, 1. 0 Is that always the case? 8 plus... Really? I guess that is. So 8 plus 1. Okay, now that would be 2. No, that would be 1. Wait. No, this would be 7 plus 1. Okay, wait. 0, 0. 0, 1. 0, 2, 0, 3. 0, 4, 0, 5, 6, 7. Sorry, 5. 0. Alright, that was my brother. I'm sure he's going to watch this episode to see himself. Crazy. Alright, so this is 0, 0, 0, 1, 0. Is it 0, 1? So 0, 1, 2, 3, 7. Okay, 0 up to 7. 0 up to 7. Okay, 0. Okay, 0, 0, 1. 0, 2. 0, 3. 0, 4. 0, 5. 0, 6. 0, 7. Then we go back to 1. 0. 1. 1. 1. 3. Oh, sorry, 1, 2. 1, 3. I guess that, wow, it always works. I guess it always works. That's crazy.
Modulus operator will divide the first number by the second number and return the remainder. This operation achieves the result we want. Now, the second type of loop we'll be looking at in this video is the while loop. A while loop simply runs while a certain condition is met. So perhaps we have a bool called doing something, which we set initially to true. We can then say while doing something, and now this loop will run until the doing something bool is set to false. Now, there's nothing a while loop can do that a for loop can't, and vice versa. For example, the following code will make a while loop.
There's nothing a while loop can do that a for loop can't. And vice versa. Okay.
Loop behave just like a for loop, but
Wait, I think there are some things a while loop can do that a for loop can't. Because wait, it doesn't have to be an integer? Does the initializer, what is it, initializer, have to be an integer? If it doesn't, then... No, but what would the iteration be? I don't know. I don't know. I guess he'll explain it to me. Maybe.
something, and now this loop will run until the doing something bool is set to false. Now, there's nothing a while loop can do that a for loop can't, and vice versa. For example, the following code will make a while loop behave just like a for loop, but it's not as concise as using a for loop. In the same way, if we leave out the initializer and iterator sections of the for loop, and just make use of the condition section...
What? You can do that? You can just leave them out? That is okay. 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 There you go. Never mind.
Then we've got the same behavior as a while loop, but the syntax is kind of strange with these two extra semicolons. So you can see that both loops serve a specific purpose. In general, we use a for loop when a specific number of iterations is required, and we use a while loop when the number of iterations is unknown or difficult to calculate. We've already seen a practical example of where a for loop is useful, that being assigning values to an array, but you can imagine many more, such as spawning a certain number of enemies into a game, and so on. It's more difficult, however, to imagine cases where you don't know how many times you want a loop to run, but as one concrete example, the first step in some 2D dungeon generation algorithms is to start with a bunch of rectangles for each room, and then to keep nudging them away from one another until they no longer overlap. Obviously, you won't know in advance how many iterations that will take, which is why the while loop is an appropriate choice. We'll see another practical example of while loops in the next episode.
Interesting.
The third type of loop is We'll see another practical example of while loops in the next episode.
Sure.
The third type of loop is very closely related to the while loop, and it's called the do-while loop. How this works is you write the keyword do, followed by the body of the loop, and only after the body do you write the condition. The behavior is exactly the same as a while loop, except that it only checks the condition at the end of each iteration of the loop. As a result, if the condition is false to start the loop, except that it only checks the condition at the end of each iteration of the loop.
Okay. Sure.
As a result, if the condition is false to start with, the code in the loop will still run once before terminating. I found that I very seldom need to use a do-while loop, but it's good to know that it exists for those.
Okay. So this is for while loops that you only need to run once unless something is true. Okay. Yeah, unless it becomes true. Okay. Okay. Fair enough. Fair enough.
Those rare occasions. The final type of loop is called the for each loop, and this is used to iterate over a collection of items, such as an array or a list. We've already seen how a for loop can be used to iterate over a collection, but for situations when you're not assigning to the collection, but simply want to retrieve the values, then the for each loop is a little bit more concise. Say we have an array of strings called possible names. The syntax for the for each loop is as follows. First the keyword for each, and then inside parentheses we declare a variable of the correct type, in this case.
Hey, I was never taught about this. I'm pretty sure I was also never taught about the do while loop as well. Like, yeah, I was never taught about do while and or for each in all the courses I've taken for some reason. Or maybe I'm just forgetting.
String to hold the value. We then indicate that we're looping through each element in the possible names array. If we now print out the name variable, you can see that with each iteration it has been assigned the next value in the array. Now, there are two keywords that you might sometimes find useful when working with loops, and these work the same way for any of the four types of loops. These keywords are continue, sometimes find useful when you see that with each iteration it has been
For each, maybe I did. Maybe I did learn this one. Okay, yeah, okay. Well, I'm learning about it now, or I'm getting maybe a refresher. But I do remember this sort of syntax here. I'm wondering if in some languages it's for in, not for each. But whatever. I mean, that's useful. That's probably useful.
assigned the next value in the array. Now, there are two keywords that you might sometimes find useful when working with loops, and these work the same way for any of the four types of loops. These keywords are continue and break. Continue simply skips one iteration of a loop. So for example, if we have a for loop printing the numbers from 1 to 10, and I write if I equals 5, then continue, then it will skip the rest of the code in the body of the loop for that iteration, and so the output will be 1, 2, 3, 4, continue, 6, 7, 8, 9, 10. The break keyword can be used to terminate a loop prematurely. So if I add the lines if I equals 7, then break, then the loop will immediately terminate at that point, and so the output will be 1, 2, 3, 4, continue, 6, break. As an example of when this keyword might be useful, imagine we have some game in which the player attempts to open a locked door. We might loop through each of the slots in the player's inventory to see if that slot contains the correct key for that door. If we find the key, however, there's no need to keep searching, so his inventory Useful. Imagine we have some game in which the player attempts to open a locked door. We might loop through each of the slots in the player's
Attempts. I thought he said pretends.
inventory to see if that slot contains the correct key for that door. If we find the key, however, there's no need to keep searching, so we can use break to terminate the loop. Alright, to recap, for loops are used when a specific number of iterations is required, whereas while loops are used when the number of iterations is unknown. Do-while loops are the same as while loops, but the code inside them will always run at least once, even if the condition is false from the outset. For-each loops can be used to retrieve elements one by one from a collection. The continue keyword can be used to skip to the next iteration of a loop, and the break keyword can be used to terminate the loop.
Very
Alright,
concise
that's everything for this
summary.
episode. Until next time, cheers.
I'm gonna like that one. That one was extra helpful. Probably should be liking all of these. But hey, I mean this is a 7-year-old tutorial series. This is a 7-year-old series here. Or course. Okay, I'm just gonna say series. Whoa. The coding sloth. Problem with wind energy. What? Okay, I'll add that one. That's fine. This is what I do on YouTube here. Okay, okay. Well, whatever. That's the end of the episode. Gonna go to the next one just
Hello, in this
to
episode
queue it up. And I'm almost done. Yay. I'm gonna have to probably write myself a sort of cheat sheet for coding at some point. I think I maybe do have one somewhere, but it's not complete. Yeah, I would have to write that one to help me actually remember some coding concepts because I don't know how I can remember it all the time. Like, I know people just look things up as they need them, but I think it would help. I think it would probably help me a lot to just have a cheat sheet pulled up when I'm actually doing things and to just be able to go over them every once in a while until I have them all memorized. Yeah, I know do while, people don't use do while a lot, but that seems useful. That does seem genuinely useful in certain circumstances. So, yep, that's it for this video. Thank you for watching. It's the end of episode 4, and I will see you guys tomorrow. So, it would be Wednesday for you, even though I'm recording this on Monday, I'm uploading it on Tuesday, so tomorrow would be Wednesday. Okay, it's weird, but yep, goodbye, thank you, and I hope you have a great day.